Okay. Yeah, you can go whenever.
Okay, great. Yeah, I joined kind of in the middle there, so I didn't want to interrupt. So, okay. Concur is this UI library that I originally wrote in Haskell, and then very recently, like in a couple of hours, I ported it to PureScript. Right, so it's something I've been doing UI development for a while, like web development mostly, and this is like a distillation of what I thought a good API would look like that I wanted, and then I just went the shortest possible path to get to that API. I'm sure there are better ways of doing it, and there are more mathy stuff, but this is something that just worked, so I ran with it. So the basic idea behind Concur is that you have monoidal UIs. So you have basically the whole idea is that you can have a widget besides another widget, and then you can compose them as a monad. And then when you do transitions, you basically have a monad. So you can construct an entire UI, and then some event happens within that UI, and then you just move to the next UI, and then you just reconstruct the entire thing from scratch again. So that there's a very clear separation of generating the UI, which is mostly HTML. The current backends are all JavaScript, HTML based. So you generate the UI, and then there's a different mechanism for moving through time and handling events and going forward. So this is something that I felt was lacking in most other libraries, which had very complicated approach, and I thought that didn't scale well to most of the stuff that I was doing, especially things like in some places the abstraction was too complicated for me to change later on comfortably, and I think that this way was much easier, right? So that's why I went through this model, and so that's the basic idea. And before I started working with Concur and doing things in Concur, I played with this framework called Reflex in Haskell. I don't know how many of you are familiar with it, but that's basically FRP based, and I really liked it. It was really great, and I built some UIs with it. And the thing that really helped me understand reactive variables and stuff that I didn't know anything about before I started using Reflex was that you have a UI that returns an action, and then that action can be acted upon by other parts of the UI. So I just took that part out of Reflex, and then React gave me a really good way of rendering the UI again and again and still have it be efficient. So I just smushed those two things together and built Concur out of it. So so I don't have any slides or anything. I this being unscripted, so I just wanted to talk about it and discuss it with you guys. So I can show you. In fact, what I can do? I can probably open the examples. I wrote a bunch of examples and show you some of the things that you can do.
I've got a question for you too. You said that you first made this in Haskell, yeah, for UI stuff. What was the UI rendering thing that you're using for Haskell? Was that you compile the GHCJS and do it in the DOM?
Yeah. Yep.
Something else?
No, so it compiled to GHCJS, but then within JavaScript also it had two separate backends. One used virtual DOM and one used React. So the two separate backends. And then I also have this in progress kind of a backend which doesn't actually do DOM diffing. So it does DOM diffing, but it diffs the diffs, right? So it's like an extra layer of diffing, but the concept behind that is that it can so you construct a DOM for the first time, and then after that you just construct diffs to that DOM, and every time you construct a diff, it just diffs it with the previous diff and then sees what it needs to do to change that, so it's just more efficient. But that's not really working right now, except for some small toy things. So yeah, I just need to find more time to work on it. But the reason why I wanted to mention that was because so this Concur UI is not restricted to virtual DOM and like the whole concept of DOM diffing. So it can have other backends. And I originally also planned things beyond the web, so things like native UIs and React Native for mobile development and stuff like that. So yeah, so everything is in the works right now. Whenever I find time, I'll just keep on hacking at it. So okay. So yeah, let me open a browser here and pop some examples. How do I share my screen?
On my UI, there's a big green share button, share screen button at the bottom.
Yep. I see it.
Okay.
Okay, can you guys see my screen?
Yes. Yeah.
Okay, great. So this is the PureScript version of Concur, but this doesn't have a lot of examples, but I can just show you the 2 or 3 that I have here. So this is like the simplest thing you can possibly do, which is, so here we have, this is the entire UI that you're constructing, which is effectively just a button. And then when this UI has an event happen inside it, it just deletes all of this and moves to the next thing, which in this case is just a pure effect, right? So it just logs something and then this immediately ends. And then it moves to the very next thing, which is it shows a different button. But because of virtual DOM diffing, it effectively just changes the text here. And it shows hello sailor. And then because it's a monad, you can just call itself again and it will do the entire same thing. After this button is pressed, it will just restart from here, right? So this is possibly the simplest way of doing effects. Another good thing that came out of it, a lot of things just fell in place with Concur. So a good thing that came out of this is that in UIs, the best possible place to do effects is when you're transitioning from one state to the other, right? So this monad just makes it very clear that this effect happens at a particular instance. You can't be certain where effects happen in most other libraries, but here you can be sure that this is particularly safe because at a transition that happens, this will also take place. And in the React backend, this is also particularly convenient because then I can put all the effects that you pepper through your UI into event handlers. So I just, so every time an event happens, this UI ends. And then I take the next effects, whatever effects are scheduled, and then make them happen inside the event handlers instead of the rendering function, and then render this separately. So it's I think a bit more idiomatic for React as well. You're not supposed to do anything inside rendering. And so this worked out really well. And yeah, so this is the simplest way of doing basic UI programming. Let me show you some more examples. So this example shows another core concept of Concur, which is doing multiple widgets at the same time and basically joining them together as a monad. So here, this is very Elmish in syntax, and I like this syntax, so I just adopted it. Basically, this is a counter widget where you have up and down buttons, and then you have a label showing the current count, right? So here, it's very easy to read. So you have a div wrapper, and then inside it you have a paragraph, and then inside it some text, and the text shows the current count, right? And you can see that the current count is a parameter to the counter widget. I like functions for abstraction. Things which are too complicated, I think they just make it harder to refactor later on. So the whole idea behind this is that if you want to change the count, you just call the counter widget again with a different count parameter. It's just as simple. And of course, you can wrap a state monad transformer around it or something like that to make it implicit, but it's still, underneath it's still just parameters to functions. So yeah, so, sorry, did someone say something? Questions?
Well, I guess I was curious about the text button function.
Oh, okay. Yeah. So,
like, how does like the action get triggered from that? Like you can only attach like here I see that dollar, right, count +1, right? How, like, what event triggers that count +1 action?
Okay, so
is that like only the on click, or like what if I want to do like an on hover event or something like this?
It's on click, and I can show you the code. It's pretty small for the text button. So I just created like a small set of widgets for this. So these are the widgets that I created, and it uses some more lower level functions that are inside Concur. So text button itself is basically a display button that, okay, so at the highest level, what it does is it wraps some widgets inside a button, right? So it handles the click, and then it has some others. So this W is another child widget inside the button. So this can have its own events that happen. And then the button can have a click event that we handle here. And what this thing does is that it either returns the button event, which is a unit because it doesn't have any other information attached to it, or it can return an event from the child widget, right? So this is like a simple wrapper over child widget. And it will return the first event that happens, either the button click or something from inside the child. And then I just specialize it a bunch of different times. Like if you have only static children, then I call it a display button. So it just, ignores all events coming from the child and then just returns a unit. And then there's a specialized text only button. So it's like this, but it takes a string instead of widget to display, and so on. So it's a simple series of becoming more and more specialized. And then overall, there is this event, which everything uses this event thing, which wraps a DOM tag around a widget and then handles some event on it, right? So it's some code to handle those things, right? So these are some things that you can define yourself. It's not really something built into, it's not very low level. It's still high level, but it uses some things which are slightly less convenient to use in normal UIs. So yeah, so right now it handles only clicks, but you can just extend this and make your own thing which handles other things, right? Should I move on? Does that answer your question?
Yeah. Yeah, I think somebody else had a question here. Let me take a look. In that very first example, what would happen if you left off that hello widget at the end, like that recursive call?
It just ends. So okay, so that's a good question, because so what happens here is that after this, the program doesn't know what to do. So in this particular case, the runtime. I have a function that basically takes a widget and runs it, and this is pretty much based on a free monad. So this is like a free monadic structure under it, and then when it gets a final value and it doesn't have any continuations attached to it, it just says application exited and just ends, right? So, in fact, I'm going to move to the Haskell library examples because it has an example that does something like that. So let me show you what happens. So, okay, I think this one does it. Oh, the source. Okay, let me see. No, this doesn't do it. Okay. I know this one does it because it has a quit button. So yeah, it's just some UI. So if you quit here, then the entire application just exits. So it just says application exited, right? So, but you can replace it with anything you want. So ideally, it should not happen. Ideally, you should never have no UI displaying on the page, right? In an actual real world application. So I wasn't too worried about what message I show there.
Okay, so I'm trying to figure out how that bind thing works. It looks like it's a sequence of instructions, right? As opposed to building up like a desired state tree, like a React tree. So in this hello widget example, text button will create a widget, and then that lift F will execute when that text button is clicked, and then it puts a new text button. So it just controls one single element on the DOM, right? So
Right.
It'll put one thing in that element, and it'll do some action, put the next thing in that element, right? So that one element,
yeah.
that one element that you put in there can be that's a whole tree of like whole DOM tree, right?
Yeah. So in fact, I'll show you how so these are just widgets, and then this is the main function. So I have a function called run widget in DOM, and this takes the ID of the element you want to put it in, and then just the widget that you want to put it in. So it's just this thing just finds a DOM element by ID and then just instantiates the widget inside it. So yeah, so it because this is React, it controls only like one section of the page. But
so if you don't do the continuation at the end of that sequence of instructions, then just that one element will be removed from the DOM.
Yes.
So if you have like 5 different Concur managed elements and just one exits, those other 4 will just keep going. Yeah.
Yep. So that's what I wanted to point out here. So this happens only in this version of the application. So so this thing is not present in the Haskell version. Like run widget and DOM, there you basically have you can run only one instance of Concur on the page. I mean, you can run multiple, but I don't provide any way of actually doing it. So that doesn't apply to that one, but in PureScript, yeah. So this is an entire. So what really this thing does is that hello widget is a complete React element. It's basically a React component, and then it just puts it in this div with the ID hello, and then it lets effectively React manager, right? So if and this never exits really. So if this hello widget ends, it doesn't have a continuation, then it just shows some text there, right? Which I showed you, application exited. So this will still keep on running. It's never going to remove the div from the DOM. Right? So, okay.
Yeah, thanks.
Okay, great. So yeah, I'm just going to show you like more and more examples, going deeper and deeper into it. Yeah. So one of the concepts behind Concur was that the standard way that most UI libraries have of doing things is that you have a list of widgets to put inside a DOM tag, and that's the default API. But this is not a requirement for Concur. So this is basically effectively syntactic sugar, where it takes a list of widgets and then passes it to a function called OR, which effectively puts them together in the page. And then whenever any one of them exits, it exits the entire thing. But theoretically, you can write your own control functions. So instead of OR, you can imagine an and I didn't write and, but it should be easy to write, that does not exit until all the children have exited, and then just gives you like a tuple, or in this case, like a triple of values, and or a list. Actually, list would make more sense because since this is a list of widgets. So you can define your own control structures over it. And
I have a question. Sorry.
Yes.
If you didn't have counter widget at the bottom, so you're recursively calling this widget, right?
Right.
Each time there's been an event. If you didn't have that at the bottom, would it just basically run once? It's like the event listener just is removed from.
Yep.
Okay.
Yep. It just removes the entire thing, all the event listeners. I mean, it doesn't need to remove the event listener because it just removes the entire DOM tree from inside that the root widget, root div, and then just replaces it with the text. So yeah, so this is it's entirely up to you to keep it alive. It's just like immediate mode graphics in like a procedural programming language, right? So you just display one thing and then you handle events and then you draw the next frame. That's one of the reasons why I think this model is also going to be very useful for like games and such, because that's effectively, and not for the web, but maybe for the web also, but especially for backends like OpenGL or STL or something, where you do want to draw an entire frame at one go. This is the model that this library also has, so it probably will map well. I just haven't explored that. So yeah, okay. So when you pass like a list of widgets, and all the widgets have to have the same type because it's in a list. So all of them have the same return type. And in this case, that's an integer. Then it, as soon as any one of them exits, it just destroys the entire set of widgets and then returns the integer output. And then we log it, and then we call it again with an updated one, right? So, and here, this is another one of those things that fell into place on its own. This widget is basically a paragraph which has a text inside, which just says something. And that never exits. Like if you're just displaying a text and it has no events, then that widget will never exit. So the return type of this is effectively for all a, right? So any display widget like this, which never exits, can be combined with anything else which returns anything, right? So we have a text button here, which at the end returns like count plus one, the next count. And we can easily put this in the same place as the text button because this can be of any return type because this actually never returns, right? So it just, and it's very useful to have these display widgets all over the UI. And if I had to do type matching, it would make everything very tedious, but you can just pepper displays anywhere and it doesn't change the rest of the program at any point of time. So that was really helpful and that worked out well. And so, yeah, so you can see that this basically is a text button. And then when this ends, instead of returning a unit because of this applicative like map thing, it just returns count plus one. And then this returns count minus one when you press decrement. And then it returns that as an n, and then we just log it and then update the counter widget with the new value of n. We just call it again, right? And I haven't written one for pure script Concur, but there is this forever thing in the Haskell version. Actually, no, it imports that from control monad, right? So I don't need to write it. It's already there in control monad. And you can just say forever and then do this and not have this line at the end. So it makes it very easy to understand that this widget runs something forever, right? And it never returns. So, okay. So that's another simple thing. I recently,
Sorry.
yeah.
To get forever in pure script, you need monad rec. Is that right?
So
essentially,
in this,
you need.
Yeah, you need that, but I realized that because I'm using React and internally it's using React set state. So what really happens is that every time the UI exits, it just does a set state with the new widget, right? So effectively, it just returns. It just does set state and then returns. So it's the entire thing is stack safe. It's like a trampoline which was inbuilt, right? So so that example that I just showed you. In fact, I had an example here, like this one, which showed that this is stack safe. So even though I'm not using monad rec here, so what it does is it just so this tail rec widget, it just takes an integer of the number of times you want to run something, and it just keeps on calling itself, like tail rec widgets, keeps on calling itself that many number of times. And I run it like 100,000 times or something. And I've tried like several million and it works fine. It just runs it instantaneously. So, and this does not have stack overflows. Right now it's kind of broken because I implemented asynchronous effects using the AF monad, and I don't really understand it that well. I haven't used it a lot in PureScript. So I just have some bugs with the way it interacts with the React set state because that's mutable. And asynchronous mutability is always hard. So it has bugs and it just blows the stack in the current version of Concur. But like before I checked in the asynchronous stuff, it was working fine. This did not blow the stack. For this, I have a function called pulse that's there just so it's not, I mean, if this pulse wasn't there, then for the first 100,000 iterations, what would happen is that tailrec widget is basically tailrec widget again, right, with a new count, where new count is just another variable, it's count plus one, right? So this does not invoke monadic bind, then it becomes like a simple function tail call, and that is not stack safe in PureScript. So that would blow the stack. So I just I have a pulse function which doesn't do anything. It just forces you to have a monadic bind, and then it's a monadic tail recursion, and that works fine. So it's just a silly thing. I'm sure there's a better way of doing it, but this worked. So I just right now that's the implementation.
Which version of app did you try using for that? Was it like I think the latest is version 4, and there's been significant optimizations with regards to stack usage.
I just did it like a couple of days ago, so it probably is pretty recent. So yeah, I don't remember the version number here. In fact, I can check. So oh yeah, this doesn't have version numbers. Yeah, so I don't know how to check here, but
we could check the package sets repository and check for app.
Right. Okay. Yeah, this thing. Okay. Yeah, so it was the latest, whatever.
It's definitely 4. Yeah, don't worry about it.
Yeah. So it wasn't a problem of optimization. It was mostly, mutability with asynchronous effects, and it was just blowing up a lot of things in places. So it's definitely not anything to do with AF. It was mostly to do with React set state. So yeah, so demo is currently disabled for this. In fact, I have the demos here. I can show you. So all of them are together here. Okay, so yeah, so this is like increment, decrement, those things, and then this thing looks like this, right? Okay. So next thing I wanted to show you was how the AF thing really works, and so this is the code for doing AJAX calls. And then the way this works is that I have a lift AF function. Instead of lift F, it's lift AF. And then you can do like AF stuff inside it. So this uses AFJAX to make the AJAX calls. And here you can see that it basically, because widget composition is so cheap in Concur, you would end up using it in a lot of places, like in a single line. So here you're making an AJAX call, and then you're also saying that while this AJAX call is going on, just show text. And this, because this is a text, this never actually returns. It has no events. So this entire thing is a widget that basically shows loading until the AJAX call returns, and then this entire thing ends. So it's like a very lightweight way of specifying your UI. And you can mix F and AF together, and that works fine. And then we just decode it and we just display. So all the rest of it is mostly JSON handling, which I just read the docs for JSON handling like for half an hour or something, and then implement all this in half an hour. So I'm not sure if this is the best way of doing it, but but this works. I was able to parse like lots of JSON stuff.
Can you explain how that loading thing works? Because how I've seen people doing that loading message in most other UI things is they'll like store some piece of state somewhere, right? And it says, is it loading? Boolean, true or false, right? And then like in the view template, they go, if loading, then text, right? Then show text loading. Else, show the data, right? So like, how is this working?
So that was one of the things I really hated, because I know loading is only going to happen once, but that Boolean stays with me forever, right? So it's always going to be true in the beginning, and then it's always going to be false, but there's no way of representing that, right? So that little bit of state always frustrated me. So the way this works is that it's, again, simple asynchronous flow, right? Fetch post is a widget that starts by just logging something, and then it has this widget. This is like a separate widget on its own, right? And this widget is composed of two widgets. So this is the alt. I don't know what this is called. How do you pronounce this? Like, I don't know. Alt.
Yeah, it's called alternative.
Alternative. Okay.
I've heard alternatively. Yeah.
Right. So the whole concept is that it will take a widget, and then it will take two widgets and then just do them in parallel. So it'll just place the two widgets together on the page, and it effectively just monoidally appends their views together. So one of the good things about Concur is that when you compose widgets using operators like this, it composes the views together and composes the event handling together in one go. And it's all very intuitive. So that's why you don't have a lot of boilerplate around this. So that's what I meant when I said that composing widgets is cheap in Concur. I didn't mean performance, but like programming overhead. So this is a separate widget. This is basically just an AJAX call, which is in AFJAX. And then I'd use liftaf to lift it into the widget monad. And it just calls Reddit some subreddits JSON, like the list of posts. And then this is a separate widget that just shows some text, and it never returns. And then when you join them together, this one doesn't have a view. And this is a very common pattern where you have some effect that doesn't have a view, and then you have a view that doesn't have any effects, and then you join them together to have like a view and an effect. So what's happening is that it will show this view until the effect itself returns, and when this effect returns, it's just going to move on to the next thing.
So that's an aspect of the alt instance of widget, yeah?
That's right, yeah.
Okay.
Yeah, and
That's
that's and that's sort of the core concept behind Concur, because the monad is fine, but then how do you do multiple things on the page? So the operator that we have, this is the core operator, and this is used every time. So when we do things like this, it's basically using this alt operator to combine all the widgets together. So it's just like a folding using this alt over the list. So so this structure where you have a tag and then you have a list of widgets, that's not intrinsic to Concur. So that's what I meant when I said that you can use your own control structures. So this is like a shortcut that basically does fold using alt with all these list of widgets. And you can do your own thing. You can do other things with the widgets. In fact, I probably can think of. So I'll move on after, if this is clear for people. So so this will basically just get some JSON, show loading while you're doing it. And you can also abstract this away. So you can create your own, like a widget wrapper, which will take any widget, and then it will add this to it. So while that widget does not have a view, while it's doing some effect, it will show loading, right? So you can think of it as like abstracting over. And then I can, so let's say if it's called loading, then instead of this kind of a thing, I can just say while loading lift af, right? So that makes it simpler to, the intent becomes simpler when you're reading the code. So yeah, so this gets the response, which is like JSON, and then it checks if there was any error. And this is just JSON parsing. In the parsing, I think this uses either. Yeah, it uses either to decode the JSON. And then if you got some post, then you just display. This is another widget that you just create where you map over the posts, like the posts array. And then for each post, you show this, right? So you just show a div with the text of with the title of the post as a text, right? So because widgets are functors, okay, but no, this doesn't use that widget functor instance, but yeah. So it just displays the title of each post, and then it shows a refresh button. So again here, because this entire thing, the displaying of the title of each post is just a display. It doesn't have any events, so it has no return value, or rather it can be any return value, any return type. And then I have something which does have an effect where this thing will return if this button is pressed. So effectively this widget is a widget that will finish when this button is pressed, right? So when you press refresh, this entire thing will end and it will call fetch posts again. So when you say refresh, it will just go back to fetch posts and then just start doing this entire thing again. So that's a simple way of implementing refresh, right? So I can show you how it looks. Yeah, so you click on fetch posts, it will show loading, it will show the posts, and then when you say refresh, it'll just do it again, that kind of a thing. Right, so it's hopefully a simple way of doing effects and asynchronous effects and things like that. And because this doesn't use callbacks, I mean, from an API standpoint, this doesn't use any callbacks. So for the programmer, it's very easy to reason about this, right? So it's a simple flow. I used to call this inversion of control until someone told me that this is the opposite of inversion of control. I don't know what it's called, like reversion of control or something. So yeah, so this is hopefully simple to follow if you take out all the JSON handling stuff. I want to show a simple example that I think, sorry, someone had a question?
No, I was just proposing that we could take a look at simple JSON later maybe and clean this up. Because there's a library which makes this like really nice.
Right, yeah. Yeah, I think it's just because the actual UI handling code is pretty small, but you know, the JSON stuff takes up the rest of the, like I'd say 60, 70% of the code, right? So yeah, that'll be very helpful. Okay. So.
Oh, I had a question about that. I saw that widget returns a value of type A for any A.
Which one?
In that fetch Reddit function, the type signature, it says for all A and.
Oh yeah, yeah.
Widget
because
HTML A.
Yeah, so because this never returns, because so you can again reason about this. So this is just a display. It shows the title of the subreddit, and then it does show post. Show post just shows a button, which when you click, it calls fetch post, and fetch post just calls itself. So it just you know, never actually ends. So you can assign it any type A. So this fetch Reddit is again a display widget. I call these display widgets which may have effects internally and may change its state, but it never actually ends and like seeds control to subsequent widgets. It never does that. So effectively, you can give it any type A. And then that means you can compose it with any other widget at any place, and it'll just work. The types will match. So while using Concur, there'll be lots of such widgets, because most of the time you don't want the UI to disappear from the page, right? So most of the widgets that are long-lived will have this type.
So that A will be some like event handler. Like it'll be the value that comes out of an event handler, or what?
Yes.
When would A have a concrete value?
A will, in this case, A will never have a concrete value. Mm-hmm. So effectively, we're saying that this widget returns a value A, which can be of any type, right? So this is like there's no value that we can return which will be a member of every single type, right? So effectively,
right. But like, which kind of widget will return a concrete value? Like this one doesn't, but which kind of widget would?
Okay. An example of something that does it, that's just a button. So like this widget here, this thing, right? This returns a unit because it just returns when you click it, and it doesn't have any meaningful value attached to it. It just returns a unit. And because this internal widget returns a unit, this entire thing also returns a unit because it's just div is just a wrapper over the button which returns unit. So this returns a unit, and then so this entire thing also returns a unit because the top line is just a display widget. So effectively, it has the same type as the text button.
So this this A it comes out so this is why you have different functions for different buttons, right? Text button versus just static button, right?
No, so actually, so that is the difference between having. So text button is something where you want text inside a button instead of some other static widget, right? So because this uses the button tag, so the button tag can have pretty much any HTML inside it, right? So so this is specialized to. So this takes a string argument instead of another widget. That's the difference between a text button and a static button. A static button can take any widget.
Okay.
So it's not output as much as input.
Okay. Let me be more specific. Question is, it looks like these UI functions, like text button, it only lets you do subscribe to like one event that they produce, right?
Yes. Yeah.
So then, in that case, if we want to make a button that allows us to take action on hover,
right,
on mouse hover over it, then we have to make a new function, right? Like text button hover.
Yes. Or yeah. So, but then once you've implemented text button hover, then you can delete this text button, and then just make it call text button hover instead, right? So because that's more generic. So basically, this is just a set of widgets that I created, like the easiest possible set of widgets that let me do something interactive on the page. But ideally, a full widget set will have more event handling and more things, right? So that's one thing, right? So you can have multiple events on a particular widget by creating a separate function. But another way of doing it is that you can create a wrapper. So a wrapper can take any widget and attach an event to it. That's also doable, right? So like if you look at text button itself, again, I'm going to go back to the text.
Oh, okay. So if we have 10 functions for 10 different UI elements, we wouldn't have to double that to make like 2 different events.
Right.
Right.
Right. So like this thing, L event, takes an arbitrary widget and just and an event handler and just pops that in. Inside that widget, so it lets.
Yeah, that was great. It sounded like it wasn't too composable, but yeah, if you have like.
because effectively it just boils down to React's attributes. So what this one does is it just creates a new attribute which has an event handler attached to it, and then it just adds that to the set of attributes that the widget has, right? So it just with the React backend, it's really easy to implement. With other things, it may be difficult, but anything to do with Virtual DOM or React, which are the only two kinds of backends that I've implemented so far, it's been really easy to implement functions like this. Okay. Should I move on?
Well, I think Gary had a question. Let me read that. Because his mic is not working. Oh, but I think it's less a question and more a comment. He thinks this is pretty great, and you could build lots of other kind of like halogen or pucks. You could build that on top of Concur. He thinks.
Oh, yeah, I've been missing all these chat comments. Yeah, I didn't even realize that there are people writing stuff. So, yeah. Okay. Yeah. Yeah. This is the thing that had me worried was that it may work for like simple examples, but may not work for something really complicated. So I've been asking people for examples that I can implement, and I'll be like, I'll do your work for free if you have a UI that you need to implement. I'll just implement it myself and give it to you. So come up with some complex UIs for me to build, and then for the Haskell one, I do have some examples of some complex UIs. Like this one, I really like because it is not a to-do list, which is what most people sent me. So yeah, so this is something that someone on Twitter just posted a while ago. And it's like a big specification of what they wanted in a program, and it seemed pretty complicated. So I just took that as a challenge and implemented it. So one of the things that was interesting in this was that this had a separate area which was display only. So it has like this entire this entire left section is display only. It just shows the current state of the program. And the reason why that's complicated in frameworks where you don't have a global state is that the state is like littered all over the rest of the program, and you have to somehow consolidate it and then put it inside this display thing. So I thought that would be more complicated, but it turned out to be pretty good. So I can in fact show you this, how this thing works. It's like, you can, so to give you an overview of what this does is that there's some game, Kirby Super or something, Superstar Ultra, and then it has 10 different bosses, and like the first 6 of them can come in any order. So you have to track the times for each boss run. So you enter time, and then you ask for the boss number like this in a list, and then you enter the time for the boss, and then it just adds it. And then you also maintain a state of global time. So you have to maintain that list and the best times and things like that. And then you have this entire display thing around it. And then you can say cancel. So I don't know if that there's a, yeah. So you have the option of canceling the run and saving the current numbers that you have entered. So you don't have to enter all 10 in one go. You can enter like 3 of them and then just say cancel run and then save new best. So just those 3 will be saved, or you can go through the entire thing and then they will automatically all be saved, or you can discard it, and so it'll discard the 3 that you have entered. So it has a lot of state and a lot of escape hatches. Like you could be in the middle of a flow, which is in the middle of another flow, and then you have to exit all the way back to the top from that. So I thought this was a good example of a complicated, like sort of complicated UI that I should implement. So I did implement it. And did I open it somewhere? No. Okay. And it wasn't very small, but I think it was pretty great. I mean, it wasn't very bad. So if you look at it again, because it's monadic and because it has state, so I just use state T here, right? It's like a state monad transformer over this, and this is Haskell, not PureScript, but pretty similar to PureScript, right? So what this does is it basically has a widget which takes the current state out of the state monad and then just displays it. Display stat is a simple widget that takes a state and then just displays it in the appropriate format, right? And then it also has the menu system next to it. So both of these two are separate widgets. And this menu system is, it has 3 options. And when you go inside start run, then what it does is that it needs to now record all the times for a particular run, and it doesn't care about the global state. So what I do is I go inside like a separate, an internal state monad, right? So I do exec state with 0 and an empty map to begin with, so this map is basically a map of all the times that you have recorded in that run. And because they can be recorded in any order, so I didn't use a list here. So, and then these widgets, they can't access the global state. Like they can't mutate the global state because they run inside this localized state monad. And so there's this separation of concern where if you're inside a particular workflow and you have to start another workflow, then you can start that thing separately altogether and not care about the global workflow that you're in. And that also means that this could be inside a separate function, and that function does not care about the global state at all. One of the things that I don't like about Elm and such is that everything is inside this one big giant data structure. And what Elm basically suggests you do is that you create a global data structure which has substructures, and then you have, I don't know, some accessors, like things that pull out data from the global state, and then you have some boilerplate code to pass it to the right widget, and then so it's there's a little bit of boilerplate involved with fetching data out of a global state and passing just that small part of the state to the UI code, so it doesn't have to worry about the global state. But I think that's too much work, and I just wanted something that can work without any boilerplate. So this thing, I mean, we already have abstractions like the state monad transformer and things like that does this, right? So you can have local states inside local states inside local states. So why not just use that? So you can do that. And in this case, I could have also used a reader monad to get the global state inside these things. But instead, I just get it in the beginning. So this is the global state. And then because they needed access to the global state to display the left side menu. And this initially I thought was kind of a what. So let me explain this. So what happens is that the application has 2 separate states. One is a global state where you have when you're just navigating the menus to enter to either quit the application or start a new run. And then there's the local state inside when you start a new run, and then you have to enter the run times. But both of them have to display the left side thing with the entire state, right? And I thought that having to do it in 2 places, just because you have 2 things, was kind of bad. But I realized later that, even though they look the same, the left side menu, even though it looks the same in both these cases, but it's not actually the same thing. And because I have this separated from this, that means that if the requirements will change later on. So you might have to, the client might say that, if you're inside a single run, then display some other thing. Don't display the global state here and remove it. So it just forces you to separate those 2 things out. And if the requirements change and you don't need to display the global state inside this, then that is just easy. Just delete this entire line from it, right? So I think that's a positive, not a negative, that you have to duplicate the thing. And the actual abstraction is, again, abstracted inside this function, display stats. So that is still, you're not duplicating code, just that conceptually the widget is duplicated, which I think is fine. Sorry, go ahead. Did someone have a question? Okay. Yeah, so what this does is that it goes inside local state, and then displays the thing, and then also enters this runtime menu. And then runtime menu is a separate thing, is a separate state. And here it's also state T, but then it uses the game run data, which is the local run data rather than the global state. And then it again does the same thing. It shows a different menu and eventually returns a Boolean, because here we have a case where we can exit it prematurely. So if you haven't entered the time for all bosses, then the global widget has to handle it differently. It needs to allow you to finish it later on, right? And if you have entered the times for all bosses, then it needs to just mark that entire run is complete and just assimilate stats, and then not allow you to continue doing that. So the return value is really only a Boolean from here, because this is the only meaningful information you're passing back to the global widget. And then, so this is the Boolean that comes out of it, whether or not we have, whether or not we need to continue doing this. And then I have a small function which merges the stats together depending on the run stats. So yeah, okay. And also with the menu thing, so if you're implementing this in Elm or anything with a global state, then you would have to represent the state of the menu itself in that global state. So you would have to have some variables that indicate which menu is currently open and which child menu is currently open within that menu and stuff like that. But you don't need to do that with Concur because it's inside a monad. So, you can just like these things, once you click on, say, cancel run, I don't need to store the state forever that cancel run is not open right now, right? I don't care about this. This entire menu has disappeared if I say cancel run. So I don't need to keep on storing the state of the menu in my global state anymore. So I think that's, in a lot of cases, a lot of the state that we have in our program is very short-lived. So I don't want it to keep on polluting my global state. And here I can deal with only the things that I care about, right? So yeah, so the rest of the stuff is basically simple generic widgets. So this is a simple display widget that takes a stats data structure and then just displays it in the proper format. And this is maybe not the best code because it uses a lot of pluses and stuff, but and then this is another widget that lets you enter time in a text box, and then it formats it, and it returns an integer. But if you don't enter the time correctly, then it just forces you to do it again. So until you enter time correctly, this widget will not end, right? So yeah, run while maybe is the function. So, and that's just defined here. So it's not like an inbuilt function. So it just takes a monadic action and keeps on calling it again and again until it returns a value, and then it just returns that value. So it's just, this is the type of that. So it takes a monadic action that returns a maybe A and then just removes the maybe from it. And so this is an independent widget that will force you to enter some time, right? And it will not let you enter an invalid time. And yeah, so this is all the code for the entire thing, and I can show you how it runs. Oh, here, I had it open. Yeah, so this is the local display thing, and you can enter some times, and it'll let you choose times. This is a fairly complex application, I would say. So if I enter something wrong, it'll just force me to enter it again, right? When it does this, and I can save this time by doing cancel run, and it just saves it. So this is, and I can reset the data, all of it. And resetting data is, again, so simple to implement because I just restart the entire thing again. It's just, it's really easy to implement. So yeah, so this is like a reasonably large piece of UI that I built, and I think this came out well enough. And as you can see, there is no global state, like a whole bunch of, this application has a whole bunch of state, but we don't need to have a global data structure that represents that state. Yeah, so I have a lot of examples. I can show you like more of those, but if there are any questions, I would be happy to take those, or there anything else you would like to discuss?
I think Gary or Kurt Creek had a question.
No.
Yeah, so Gary asked something. So he said, I did have a question actually. That's relevant to most of the stuff so far. What made you re-implement this in PureScript since you had the GHCJS version already working, etc.? Just curiosity, or was there anything particularly that motivated it?
Well, actually, people asked for it. I put it on the Haskell subreddit. In fact, I didn't make a post. I just replied to a comment, which was like, what are you working on that's interesting? And I just replied to that saying, oh, I'm working on this library. I didn't expect a lot of interest. And then people said that this is nice, but I would like a PureScript version. So then I didn't do it at that time. That was like a couple of months ago. But recently, I just felt like playing with it. And I was reading PureScript React's implementation. And I thought that looked pretty simple to use. So I just went ahead and used that to implement it. That was the simplest thing that I could think of to implement it. Right now, I'm thinking of implementing it using Halogen VDOM. So that looks a little bit more complicated. So I still haven't spent enough time doing that, but I'll probably do it. There's someone else who's opened a few issues on GitHub, and he already has like a working Concur implementation that uses VDOM. So I mean, there's like a small gist of something that works. So I plan to take a look at it and see if I can adapt it into a common thing which can work for both React and VDOM. And in fact, after I posted the Haskell version, someone went ahead and implemented it in PureScript themselves, and that apparently didn't work out too well for them. So but it did work, So I was motivated by that it's possible, but it may have some kinks. So it's a good thing to try. So. And I myself was excited about the PureScript version because I don't work. I didn't at that time. I didn't work as a PureScript programmer, but I am doing some PureScript work right now, and it just was a good way to practice my PureScript skills. So I'm just getting started with it. I don't know a lot about PureScript, but because it's so similar to Haskell, so it just works for me. But there are a lot of concepts like this asynchronous stuff was entirely new. I had no idea how to do that in PureScript, so I'm still learning about that. I was very happy to see the parallel. I don't know what the library is called. I've forgotten the name, but there's a library which does parallel computation, and the AF has an instance for parallel computation. So I think that'll just be very useful for this. I can probably just directly use that. So yeah, so I'm excited about the PureScript version. In fact, I haven't touched the Haskell version for a while now. So yeah. Yeah. So.
Can you not bring up the chat yourself? Or I mean, I can if you can find it. Otherwise, I can read his response.
Whose response?
Gary, the guy who asked the initial question, basically. Maybe somewhere where the presenter thingy, does it put like this little widget on your screen somewhere? Is there like a chat thing that you can click on? I think when I present.
Sorry, so are you asking me to bring up the chat window?
Yes.
I already have that up.
Oh, I see. So you can see his response. So I'm just.
I just I just saw it. So I have like different screens and I just keep on switching between them. So so I have the chat window open now, so I can see it. So okay. So okay, so are you saying that halogen VDOM is more suited to this than React, or are you talking about the AF thing? Halogen VDOM? Okay, great. Got it. Okay, yeah, I'm excited to use it. Yeah, the VDOM thing, I assume uses the JavaScript VDOM library, or is that like an entirely new implementation? Does anyone know?
Oh no, it's a native PureScript one. It's
Oh,
all written in
great.
PureScript. For efficiency reasons, some of it is written in JavaScript, the FFI files, but otherwise it's all fresh.
Okay, great. Yeah.
It's
yeah,
nice because you don't need NPM anymore, basically.
Mm-hmm.
Right. Okay. Yeah, that's great. Yeah, I'm excited to try that.
Can you explain the definition of that widget type?
Which one?
Because it sounded like that was pretty interesting. How it lets you do view stuff as well as actions.
Are you talking about this Kirby Superstar Ultra example? Something?
The widget, because when you're, binding widgets and lifting Fs into the widget.
Oh,
that widget type.
The implementation of widget. Okay, yeah.
Yeah, the implementation of the widget type.
Yeah, right now it's extremely simple. So the concept behind it is that it's just a free monad. This is just a line that snuck in. It's not used anywhere, but effectively it's a free monad because it's basically a widget can either end or it can show a view with a continuation, and then because this is a free monad, so I can kind of interpret it inside my thing. So eventually it goes down to this thing. It just creates a React class, like React component out of it. And I have some comments here because it wasn't really working. I was trying it, but okay. So, and what it does is if the widget ends, then it just, hang on. Oh, why is it not? Okay, I can't click on it. Okay, now I can. Okay. So if the widget ends, okay, not this. Here. Yeah, this is the render function. So it just reads so it just gets the current widget. If it ends, then just doesn't display anything. So in this PureScript version, I don't display anything if the widget ends. It just shows a blank thing. In the Haskell version, I show application exited, but it's not the case here. And if it has a continuation, then it just creates a special handler, which will, when the next time a widget is passed. Okay, so the handler itself, okay, I should probably explain that better. So the way this uses React is that it displays a view, and then the handler for everything inside that view takes a new widget to display, right? So I just use React for plumbing effectively, and the handler itself, what it does is when it gets the widget, it runs any effects that come with it, and then it just displays the view. So that's the overall concept behind how it's implemented. And this is just the concrete implementation, which is slightly buggy because the asynchronous stuff kind of gets in the way. But yeah, so that's how it works. It just writes states with the widget and exits. And because you've done write state inside the event handler, it just calls render again, and render gets read state and gets the new widget. And thankfully, React states can be anything. So in this case, it's a complicated widget that I just get in the render function. So yeah, it's a pretty simple implementation. In the Haskell version is slightly more complicated because the React bindings were kind of immature. So I just wrote my own, like, really simple ones. and that doesn't support a lot of things. So the Haskell code itself had to be more complicated to accommodate those changes.
You talk about your code like I talk about my code. Yeah, it's pretty good. It's buggy, but it does its thing. It works. It's not bad.
That's right. Yeah.
That's how I talk about stuff I write. It's like a big caveat about.
Yeah,
it works, but don't expect too much.
Yeah, it's my baby. I know it's wonky, but yeah, that's exactly how I feel about this.
And then people tell me, "Oh, but you should be more proud of what you make." Well, I know the shortcomings.
Yeah. Yeah. So
Bad design.
I don't know if this is the best way of doing things. So, but yeah, it works. But that was my concern.
Mm-hmm. Yeah. Any other questions? Or maybe anything else that you need what you want to talk about, Anupam?
Nope. That's pretty much all I had.
Okay.
So yeah, thanks guys for inviting me to this. This is pretty interesting.
Yeah, this is really exciting. This gives a good context for, at least for me, to go through and check out how exactly it's implemented. And
right. I'm really bad at documentation, and I think the documentation really lets this entire project down because you just like if you go to the Haskell, if you go to the PureScript version on GitHub, it doesn't have any documentation. It just has like a small blurb and a link to the main Haskell library. And if you go to the Haskell library version, it has like 2 pages worth of ranting. So it's just a lot of text that it's like stream of consciousness kind of a thing. So that I wrote. So I just need to write better docs for this and explain like the motivation and differences from other libraries and things like that.
No, you can write docs when it's done, right? Just whenever it's done.
Yeah.
The best thing is most code is never done.
Right, but whenever it's complete and bug-free and perfect, then I'll get down to writing docs. That's basically every developer ever who does that.
I don't think you can ever call anything actually ever done, though.
Right. Yeah, that was the joke I was trying to make.
Mm-hmm.
So,
yeah. I wonder if we should move on to something else. If anybody else has something to talk about.
Molly's musician said in chat that he'll be here in an hour ago. So maybe until that Boolean talk, maybe you could present the fetch, and then when he joins, are you still not doing that?
Yeah, John also he came a little bit late. So whenever Anupam was finished, we were planning to have him talk about the monthly changelog, do the monthly changelog of the PureScript ecosystem again.
Yeah,
I always like seeing that.
Won't take very long. All right.
yeah, I'm pretty much done. So,
Thanks a lot, Anupam.
Okay, thanks guys.
Yeah, I think I'll need to requisition the screen share.
Oh yeah, okay. Stop sharing.
All right, okay, now I can do that. All right, updates for like the last 2 weeks, because the last time we met together, which we do, but like I still haven't discerned whether this is like a hack session or sharing, because it's usually a bit of both. Anyway, last 2 weeks, this is what happened. Next. All right, so in the contrib, not repo, but like organization, machines was updated. I somehow lost the line that was related to the update, but I think it was basically something like there's a foldable instance, like 2 unfoldable, I think, that was added to the mealy machine in there, type that was in there. Somebody knows the details about that, please let me know, but that's what that was. The React package got some updates. The create React class dependency is removed, and that took along with it the create React or create class function and the spec function. And now it's just using stuff that's derived from React component and React pure component. So like from the actual JavaScript classes that are there. And there's an on-air prop that was added that you can include, I guess, to catch any weird errors. I haven't used React in PureScript, so I'm not sure how that all works, but from what I can gather, reading the docs and looking at the type signatures, I was like, oh, I guess this is what it does. which is kind of cool if you think about it. Like, I have no idea what the hell this package does, but I can look at the types and be like, oh yeah, okay, maybe this is how it fits together, which is pretty cool. All right. In the PureScript organization, these are some of the packages that got updated. So F now has semigroup and monad instances that are there. Non-empty is now foldable, one, I guess, added there, which is kind of neat. And Gen was also, well, Gen got non-empty, that got generalized, the foldable one, which I think is pretty interesting. Arrays, oddly enough, has a non-empty array now instance. I don't know if it's an instance or like complete implementation there. So I wonder if that's also going to get generalized to foldable one at some point. I don't know. That was pretty interesting. Quick check. There was a. Sorry, go ahead.
I was just curious if you knew how that worked, the non-empty arrays, but it doesn't sound like you do off the top of your head. So I guess I'll go take a look at the package.
Yeah, I don't know. I briefly looked at the code and I was like, oh, here are all the non-empty related things that I would expect anyway. So I'm not certain how that's implemented. Sorry. My guess is it's similar to how the list one is implemented. That's my guess.
Yeah, the PureScript arrays package, that's mostly wrapper around the native JavaScript arrays, right?
Right.
And generally people use that to feel a little bit more efficient.
Yeah. Yeah, if you're doing...
So this non-empty one, is that like also kind of just a wrapper around some JavaScript native one?
So yeah, Gary's answered in the chat. He says it's a neat type over normal arrays, but can only be constructed safely.
Oh, okay. So it's just the construction part of it.
It's a little bit more than that, but yeah, from what I can see.
I suppose like some removing operations too.
Yeah, let me see if I can bring that up. I just had it up here. Arrays.
Yeah. Because yeah, if you're going to remove elements, that's going to have to return like a maybe non-empty array.
Yeah.
I imagine.
Or just a regular array, I guess.
So there's some JS stuff that's there, some interop. I'm not going to go deal with that. But from the export list, I was like, oh, all this stuff is implemented, which is.
Oh, this is a big addition.
Yeah, it's pretty huge. It's sort of equivalent to the I guess the expectations that's already there in the array package. So I mean, obviously a bunch of it can be derived, but that's fine. I don't know the details about this. All I can say is it's quite comprehensive. So there's that. That's about as much as I'm willing to say about something that I don't know the details of. Anyway, y'all can take a look at it whenever. Back to the little Sherry thing. Where'd it go? I think this is the screen. Yeah. Quick check part was interesting reading about. Like whenever you have a generator and you call resize for that, the seed is now modified as well. So now you get a new seed along with the resize operation, which I thought was pretty interesting. Anyway, there's that. This thing that says gene, that says exported filtered. That just should be gen, the gen package. There's a generator for that as well that now exports a filtered one, which basically says, hey, use this generator, but FYI, filter out all these values I don't care about, which is kind of neat to have in the generator when you're using that for values. There's that. PSC package, so a whole bunch of good stuff in there. There's a new version out, FYI, if you want to pull that out. It's got a couple of new things. There's a formatter that's there for packages JSON that's built in, so you don't have to manually format that file anymore. Hooray. And there's implement added from Bower. So that's usually like one of the contentious, not contentious, but like one of the things you often miss out when you're saying, hey, I'd like to add a package from Bower, but since I'm using PSC package, I can't really do that. But now there's a command for that, which is pretty cool. So now you can have your PSC package sets, and you can have stuff from Bower as well. So that kind of helps you build your own local package set, if you will, but you don't have to like fork off the official. I mean, you should fork the official one and use that. I think that's the intent, but you don't have to, I guess. Which is kind
so the add from Bower is like a maintenance tool for maintaining, like adding stuff to a package set. And that could be used for that central package set.
Sure.
Or if you want to just maintain your fork of a package set, you can just add from Bower into that one too. Like it's not meant for just like on your own computer, just one package set there. Well, I guess you could too, just a package set. Yeah, you're right.
Yeah, you can do a bit of both, right? Like if you fork your own, obviously you're going to modify it anyway.
But then if you want to share that package set with other people, you're going to have to push it up somewhere.
Correct. Yeah.
Mm-hmm.
So yeah, those are a couple of new things that were installed, and there's a bug fix there where if you just type in PSC package install, it pulled the entire dependency tree. So now it no longer does that if you didn't specify a package. A couple of package sets that are added, those 4 that are there, and Express was bumped a little bit, which was pretty neat. And the compiler itself got a few different patches, I guess, that were merged in. The first couple, or the second one, was pretty interesting, which was there was a case where equality checking was sort of, or pattern matching, I think, I'm not sure which one, but basically it was super slow, like really bad. And so there's a couple of fixes that got checked in, which are related to the equals and OR instances. So basically, instead of using the stuff that's generated, I think, it's just specifying a custom instance for those two, for source span and binder, or I guess source span, yeah, in binder. So it's a lot quicker now. So I think, I don't remember who found that. Maybe it was Matt Parsons, I'm not sure, or maybe it was Modern Musician, I'm not sure. But somebody did, and then, oh, Chris Allen. Oh, there you go. A bunch of people are like, oh, Chris Allen did it. And there you go, and Matt. Anyway, so there's that. The let pattern desugaring less brittle, I'm not 100% certain on that, but Chris could probably answer that better than I can. But
yeah, well, that's not a user-facing change. The code relied, like there were some pattern matches that relied on the parser inserting position information in some spots so that like it didn't traverse all the way through. So yeah, I found that with Phil when I did a little, like a different refactoring, but I remembered that I still had that code, which was supposedly better. So I PR'd it and we got it in there.
There you go. So yeah, that's all the, so the first one that was pretty interesting to me is the errors can carry multiple positions. It'd be interesting to see how that ends up being used.
Well, the primary area this is about is when you have like cyclic imports, for example, if like 3 modules import each other, there's no canonical one that you can pick and say, this is where the error is, because there's more than one.
Got it. Yeah, that's a good use case for that. Yeah, that's pretty helpful. And that's that in the last 2 weeks. That's what happened. So, hooray.
Awesome. Thanks, John.
Yep.
Let's see, what's next? Oh, let's see, Modern Musician got here now.
Yep, I'm here.
Did you want to talk about your new free thing?
Yeah. So the actual project itself is a bit of a mess right now because I have like not just the free Boolean stuff, but I also have my experiments with CSS. Let's see, share my screen. Okay, can you see this? In the document, Google Doc, I put a link to my repo, which has these notes on it if you want. And that won't go anywhere. Okay. So how many of you are familiar with like the Boolean algebra stuff?
It's ands and ors and
yeah,
this, right?
Yeah, so I think I'll go through that a little bit. So this is just some background. So you have like some HTML structure. Everybody should be familiar with HTML here. And then your CSS selectors will select out one node or several nodes from that structure, and then you can apply rules to that. So my notation here is, so you can have an immediate child selector. So div is right below body. So that's what the greater than sign means. And then these are just elements. You can select an element. And then there's also attributes like an href here. Class attributes have their own syntax because, you know, CSS. You can also have a distant child, so like any descendant. I represented that with a square just so we have something to look at. But in CSS, it's just a space. So you would say body space I, and that would select this element. I think I used the right tag for that, not sure. And then, so that's vertical. And then you can also do horizontal relations where, so this says we have a paragraph that's an immediate child of a div, which looks in the structure like that. And then we select the one right next to that, so that if we follow the arrow around over here, that points there. So it's any like sibling, direct sibling after whatever that specifies. And then you can have a more distant sibling relationship where we're pointing to an I node here. And then we select any bold nodes after that, which end up being those two. Yeah, so that's CSS. Yeah, so I grouped these into vertical, horizontal, and then immediate and distant. This distinction will help when we're considering things later. Attributes, elements, and then if you want to match multiple things, you use a comma. And then there's a weird negation selector. I have not actually tested any of these CSS rules, but I assume the negation selector works like this. There's a couple weird rules around it, like you can't nest a knot within a knot. But that isn't a concern for what I'm doing. Pseudo classes, pseudo elements, those are weird, but you can deal with them. And then there's also the star or asterisk, which matches anything, which is not so important in like CSS rules in general, but it is important in making sure we have a full Boolean algebra with everything we want to support. And then there's no like false or match nothing, but you can just negate your match anything, and that works. So now from the Boolean algebra side of this, there's like the classic Boolean data type, which is true and false. And there's a number of useful operations you can define, but primary one are what is true, what is false, how do you negate it, and then conjunction and disjunction. So conjunction is just and you probably have an intuition from that just from like using language. Like in linguistics, we'll study like both and. In Latin, that turns into et. And then disjunction is either this or that, or maybe both of them too. And then Boolean algebras, you can have not just the Boolean data type, but you can lift it over a tuple. Get two of them working together, and it still satisfies a bunch of laws. And then you can do predicates here. So we can have some element we're matching on and then produce a Boolean result. And we can combine that in the same sort of ways. So we can match a keyword instead of like giving this an argument and matching the argument against all of these, we can just combine these predicates like that. So then there's algebraic properties of Boolean algebras. This is where the monoids come in, of course. Everybody was waiting for that, I'm sure. So there's a lot of properties here. I'm not going to lie, but commutative means we can flip everything around. So A and B equals B and A. Monoid implies associativity and identity already. Idempotent is the one that sort of distinguishes this sort of pattern, where if you add an element to itself repeatedly, you just get the element back. So A conjunction with A will always result in just A, whatever A is. And so that isn't important in the Boolean case, but when you have something, a more complex Boolean algebra, that matters. And then let's see, can I do this? Cool. So I wrote a note over on the side here. So if you just have an operator and a bunch of values, you usually represent that with a binary tree. Or sort of thing, like a abstract syntax tree. But if you know that your operation is associative, you can collapse structure a bit and you get a list out of that. You don't need to remember how everything is associated and which was on the left and right and whatever. You just need to remember the order of the elements, and a list is perfect for that. If you also know it's commutative, then you get a multiset out of that, where you don't need to remember the orders of the elements, but how often they appear. And then if it's also idempotent, like a conjunction or disjunction in Boolean algebra, you get a set out of that, where you don't need to remember how often the elements appear, just whether they appear or not.
These are all the free structures, right? On these algebraic structures, like this.
Yeah, that's what we're working towards, how we get to a free structure.
Okay.
So you're looking for a free structure to describe a single CSS selector? Is this why you're talking about those data structures?
Yes, yes. So a free structure, I'll talk about that, I guess, right here. I guess I'll go through disjunctive normal form, then I'll explain the free part of it, and then we can talk about CSS selectors now. So turns out we have a lot of laws that relate how these things, how conjunction interacts with disjunction here, and how not interacts with these. Fun fact, De Morgan's law is a monoid homomorphism. That's kind of fun. But we can also, with these laws, we have enough power to work it into a structure that's a normal form, basically. So we will have one form of everything, I guess. We have like a canonical form. So this is disjunctive normal form. It sort of appears, it makes a lot of sense. So we're going to have a lot of clauses, and each clause will be joined at the top level with disjunction. So we're going to say this or this or this or that or that. And then inside each clause, we'll have a bunch of terms, and they will be joined with conjunction at this level. And then each term will be a variable, sort of. And it can either appear negated or unnegated. I don't specifically have an example of what this looks like, but I hope that makes sense. And then it turns out with the free structure, we don't actually have like variables a through 0 or whatever. It's just whatever data type we are taking our free construction over. So we will have a data type that represents just a little bit of a CSS selector. And then we can make a Boolean algebra out of that with this data structure, which is a little weird. But so this map here represents the conjunctive clauses. So we're going to have a lot of little CSS parts joined together with and then this Boolean is going to say whether it's negated or not. And then we're going to just have a bunch of these, and they're going to be joined with ors. So taking an example here, if we are matching a div element, and then we say we also want not to be a div element, that doesn't really make sense. So if we just turn it into false, that works well. And what that looks like in terms of map, let's see if I can pull it up here, is so here we have our, okay, this is just a representation of the map. I've turned it into an array to process it. And then we also get out a map out of it. But what we do is when we insert into the map, we have to check that it matches what is already in the map. So basically for the reason that we won't, if we have div and not div, then we know that's going to result in false. So we just want to get rid of that clause. That makes sense. So maybe I should walk through this a bit more. Okay, so my normal form here, I have two representations for it. One is the set and map thing, and then this is just the unfolded representation in terms of arrays. And then we're taking the array version, and then we're mapping over each one. And then this just turns the maybe back into the data structure we want, which is an array. So how that looks like is we take every element that already exists in there, and we're going to just give it a just on there. And then we're going to generate a map back out of it. And then if we have two keys that we want to insert into the map, we're going to make sure they agree with what their positivity should be. And then if they don't agree, then we're going to just cancel out that whole thing with sequence there, and that disappears. And then nothing will propagate if we happen to have lots of duplicate keys. So that's one of the normalization properties there. And it helps us maintain laws and simplify structure because we don't want to end up with a complex structure. So this is just some examples. I can pull up the data type here. So our data type is so here's a selector. It's going to be our normal form over the select type. And this select type has an element, a class, a pseudo class, or a pseudo element, or an attribute. So in order to say div.container, we need to conjoin both a div selector and a container selector. And then we can also disjoin them and say div or a container, and that renders like that.
So you have a function that will take this data type and render it as a string?
Yeah, I do. That's show.
Okay. And as part of that rendering, it will do some optimizations? Or just having it in normal form is the optimization?
Okay, so there's a mix of it. The normal form gets us most of the way there. And the reason we're using disjunctive normal form is that's basically the structure CSS has. You have a bunch of cases, and you have a lot of conditions for each case. So that gets us most of the way there. But if we look at this example here, div and body, well, nothing is going to be both a div element and a body element. So that's where the next round of, oh, I know this is a CSS selector. I know that div and body can't coexist, so I'm going to turn those into false.
Why do you turn it into false? I mean, it seems like it's throwing away information, or...
Yeah, but well, I mean, it preserves, well, okay. So how would you write a selector that matches only if it's both div and body? In the CSS syntax, because the CSS syntax sort of deceives you. It says, oh, you can just like, join things with a dot, right?
Yeah.
Except you can't do that if you don't have a dot.
Right, for elements. And the dot indicates a property of a element, right?
Yeah.
So if you have div dot container, that's like it has the container class.
And you can just...
And you can do more classes on there too, right?
Yeah, but it doesn't work with elements, which makes sense considering how elements work.
So if somebody wanted to use like your library here to take like a div element and conjoin with a body element,
yeah,
then that produces this false value.
Yeah, so that would be allowed. It gets dropped from everything, basically. And the nice thing is you can just join things with Booleans, and you don't have to worry about what the CSS syntax is. My library will figure that out, hopefully. Okay, and then there's also more complex statements. So if we want either a div or span element, and we want it both to be a container class and be hovered over right now, then we're just going to do div container hover or span container hover. If we say we don't want it to be both a container and hovered over, then that ends up, because of De Morgan's law, that ends up as not container or not hover. So we end up with 4 cases to check there. And that looks like a Cartesian product, which fits well with the apply instance of array. But because of our issues like div and body, we actually need bind to do a little more, because so we can remove things, basically. Is that making sense so far? Yeah, I can continue my thing here, but then it gets really complicated, and just want to make sure everybody's...
Yeah, I think can continue.
Yeah, so this disjunctive normal form is it appears everywhere, sort of. So not everything forms like a Boolean algebra. It might only be like a semi-ring, but like this BNF syntax I faked over here, it looks like a bunch of disjunctions, and then you have to have this and that and that. So it's sort of like that. And then algebraic data types are, of course, we have a list of cases and things each case must have. But you don't really get to negate things in an algebraic data type.
It's only a hating algebra.
Yeah,
hating algebra, yeah.
Yeah. Okay, so now the question occurred to me, which was my downfall for the past couple weeks. How do you do this with like the combinators for selectors? So if we have two selectors here, I'm just going to start referring to them more as variables now. If their relation is immediate, then we can just say, well, something that is has class B and is immediately below an A node, and also has class D and is immediately below a C node, then we just do B and D here, and then A and C here, and we pick the same relation. That makes sense. Then we can sort of follow the same logic here because these are all immediate relations. But because we're mixing horizontal and vertical now, we, oh, there's a typo here. I need a DNA. I thought I was doing so good. But so we'll start at the end here. We'll join D and H together, and that should be there. And then we'll look at the next horizontal level. So we see C and G here, and then B and F. And then this selector sort of runs out, but that doesn't matter. We keep following the other selector. So E plus BF plus CG. And then there's this A left over here, which is at another level. So we add 2 vertical levels here and 3 vertical levels here. So we ended up with 3 vertical levels. Yeah, my comment over here is you start by assuming the B and D are the same. And then if you have an immediate relation, then you can assume the next ones are the same node. Okay, now it starts getting complicated. Now we don't have an immediate sibling, but these can be, so the A and B here can't be the same element, but they can be 1 element apart or 2 elements apart or 3 or basically any number of elements apart now. And then we have something over here where C is, where D appears sort of anywhere after C and E appears immediately after D. So I started thinking about this and I was like, we sort of need to do some cases here. And we need to see how far back A will go. So we know B and E are the focuses, so they're going to be the same. We're going to end up, I dropped B, I guess, but this should be B and E all the way down there. But we don't know where A lies in relation to these. So we know it's not going to be at E. And then we know it can't be in between D and E because we have that immediate relationship there. So I drew a 0 there and I crossed it out because we can't go there. So the next place to check is D. Can it be at D? And yes, it can be at D. So we can put the A there and just keep the structure around that. Makes sense. Now, between C and D, we can have potentially a lot of elements. So we can put A in there. And we will have distance selectors here. I think that makes sense.
This is complicated. Where does the complications come from? How to generate the CSS style from, or the selector from this?
Yeah. So
or how to do this function like in pure script.
So
describing it in pure script as a Boolean algebra, that doesn't quite work out, or it does work out, but how to generate the selector string doesn't.
Because we're stepping outside of the CSS syntax and saying what are all the operations we can do on it, and then we have to force it back into the CSS syntax, which to my knowledge does not have like just conjunction like this.
So if we write this selector you have here, like A tilde B and C tilde D plus E, like will that make the proper CSS selector string? Is it just a matter of generating the right string and it's fine?
Yeah, but to fit back into the CSS syntax, we need to go and consider these ugly cases and generate.
So it still fits into the Boolean algebra.
Yeah, I'll go over the caveat later.
Yeah, it sounds like this could generate some pretty gnarly CSS strings.
Yes, definitely.
But I suppose it's better than writing them by hand.
Yeah, this is where it gets away from
you can compose them with different functions.
Yeah, I was like maybe you could use the Boolean algebra aspect as a replacement for the specificity, which is an ugly part of CSS. If you could just say like, I want an A node to be highlighted when it's a child of, I don't know. Here. So maybe if you like specify if you make sure you're I don't know how to explain this, but normally you would have like, and then you'd have a style here, and then you'd have some other case, maybe where you say, no, don't do that. And then you start wondering about specificity. How do you know that this style will get applied over that? But maybe if you use the Boolean algebra aspects of it, you can ensure that you can generate a better condition for this that says, I'm specifically not, so you don't have any overlap.
Can you talk a little more about the, not the CSS part of this, but the Boolean algebra part of it? Because I was looking at this last week, and you had something about the free Boolean thing, and then you also had this normal form thing, and you were just doing the normal form.
Yes.
Like, what does this free thing allow you to do generally with it? Because you can take any data type and just build up a data structure of conjunctions and disjunctions and knots.
Okay. Yes, so this is like what I originally came up with for a free data type. I'm not very familiar with free data types, but my understanding is you take all the operations and you basically represent each of them in your data type. And so I have true here, and then this is, I'll save that for last, and then or here, and then not. So if I want false, I just say like not true. So because false becomes redundant, and also and could actually be expressed with that, but that's a little ugly, so I didn't include that. And then there's also your actual elements here of your thing you're taking it over. And the best explanation I would come up with for that is they sort of act like free variables in your thing. So if you want to run this, you would like give Boolean values for those variables. And so by default, the free construction just assumes they're all independent, that A doesn't have any relationship with B or C. But as we have seen, that is not the case. We know that div and body can't coexist. So there's room to do more on top of that. Anyways, but so you can take operations on it and you get out a data structure. And then what you can do is this lift free, or I think this should really be called lower, but I'm not, I just copied it from somewhere. So you can go to a more concrete Boolean algebra out of that. And so it will go through the structure, and if you have an element of the A type that you just plopped in there, then it'll put your function on that. And then otherwise it will use the actual Boolean algebra functions to go run over the structure and see what you get out of that. And then I started trying to write simplify, and I realized that there's a better way to do that, and that's the normal form. So maybe like an example of this lift free is if we do have a CSS selector. So say we have an element. We could generate a predicate out of this, like there's I don't know, there's probably I think tag name is what we want. So we could just say, oops. So we will take a, what did I call my data type? Select. So we can take a select, and then we can turn it into a Boolean algebra by taking an element and then returning a Boolean. So we can say, I'll take that and then we'll just like match on that. And then that will take our free construction and turn it into something we can actually use within PureScript. And then you could write ones for other things here. That would probably turn into an F before long, because you're matching on the current state of it. And so that's how you get out of the free structure to something more usable. But you can inspect this structure like any free structure. And
so lift free will take it out of free into Boolean algebra?
Yeah. So in this example here,
But for that CSS string, you want to turn it not into a Boolean algebra, you want to turn it into a CSS selector string, right?
Yeah.
You wouldn't use lift free.
Yeah, so at that point I just unwrap it and convert it to arrays.
Okay.
And then do all this.
So if you wanted to use something, if you want to use this free Boolean thing to make like an SQL predicate clause.
Yeah, you could do that.
So we just make a data type that represents the different types of predicates you can do in SQL, right?
Yeah, I forget what they would be, but. And then you need to consider like whether you can stay within the syntax. So that's what I ran into. So I figured out my algorithm to combine these in general. This is a little diagram I can walk through, but probably won't right now.
Yeah, we're running up against the end of our time slot.
Yeah. But then I realized that this algorithm, did I put an example anywhere? It works for conjunction, which is what we need. Disjunction is in CSS, is just putting a comma in there, but we can't negate things with this in general. So it wasn't going to really work out as pretty as I wanted. And so if we just have a simple CSS selector with no relations in it, then this data type in the normal form, where's the normal form? And the normal form work out really well. But this is what I was going to end up with as a data type if I wanted to do a Boolean algebra over selectors with relations in them. We lose some of our normalization because we can't say our nots are going to occur at the bottom level anymore. They might occur on top of a relation. So it's been a long journey to try and figure this out, but it's been a little disappointing.
It seems more enticing to just do like not support the not case and just do something more basic.
And then I was working on some
more practical.
Yeah.
Yeah.
So
that's pretty interesting. Yeah, it seems like it's still kind of well, I don't know, half-baked, maybe?
Yeah, for sure.
But yeah, this is really interesting stuff.
If you're interested, this is just the logic for how to join arbitrary relations in general.
Yeah.
It ended up fairly elegant, but yeah.
Yeah. Yeah. Okay. Well, yeah. I'm just looking at other stuff that was on the schedule for today. It looks like we ran out of time. Which is a little bit too bad. I guess that means that we'll have stuff to talk about next month, which is good.
Yeah, for sure. It's not like the Curry Howard correspondence is going to go out of date. So.
Yeah. Appreciate that, Harrison. Yeah, was it Vlad that wanted to talk about hiring PureScript? people?
Oh yeah, I said that. Yeah, because like I got like 4 interviews next week, and they're pretty
Really?
much yeah, I somehow hit the jackpot there with getting some people at least to the interview. The problem is that pretty much everybody's like very young and not like people have at most some like I did some Haskell I had a Haskell course in college, and that's pretty much it. I think maybe a couple of them have some maybe closure or some very brief Scala experience, but like obviously it's going to be very hard to find people with like years of experience in pure script or something, right? So
depends on your budget too, I think.
No, but also like I need people locally in Bucharest, Romania, right? So
right. So there's a lot of constraints, limits your candidate pool a little bit.
For now, that's what I need to find for now. So the question is like, what would you look like? Like, what would you ask us? Like, you assume that people don't know maybe a lot of even functional. So like, would you care about math? Would you care about like how excited they are about learning stuff like how would you do it basically?
I know in my experience, what I've done is just show me some code that you've written before. And if you don't have it, then, we can do some practice problems together or something. And then just explain the code to me. And if I think it flows reasonably and it's not crazy code, it understands that they've kind of understand the ecosystem and the philosophy, and that's good enough for me. Like if they got a good start, and that's good enough for me. But if you want like somebody, it depends on what you want them to do. If you just want to make some web pages, then you don't need super like PhD people to do that for you. But if you want them to implement an SQL or like some STM, like some solver or something complicated like this, then you might need to ask different interview questions.
Yeah, that makes sense. No, I mean, I wouldn't say we have stuff like as complex as IOHQ or HQ or whatever, right? Like cryptocurrency, crazy math, writing DSLs all day and stuff like that. But like we have a fair amount of like things that are not just render this text in a box somewhere, right? So it's obviously it's somewhere in the middle, right? So yeah. So would you do stuff like, hey, let's try to, because I'm trying to figure it out. So would you do something like, hey, let's try to solve a small problem on a like whiteboard or something? Like let's write out some types, some functions, like figure out something like that. Would that be something that would make sense?
Yeah, that's one way to do it. Anupam, what do you think? You said that you are hiring some people. Do you have a well-considered strategy?
So I usually take telephonic interviews, and it's really hard to get people to write an algorithm or something on the phone. But I do try to get a sense of how they approach problems. So I usually ask them questions which involve a lot of recursion or folding or something like that, and just get them to describe the algorithm. I think just as long as they know how, because hiring FP talent in India is difficult. There are not many people who have been doing this for a while.
There's a lot of people in India. It's got to be easy.
Apparently, they're all doing Java or JavaScript. Yeah. So yeah, it's I basically start with just like core algorithmic stuff, and that's good enough for me. I don't need advanced type level stuff. And usually people, if they know how to think functionally, then they can just catch up with the rest of the stuff pretty easily. So I am not really worried about that.
Yeah, Gary said just, that just following people's thought process as they work through some code. Like even just let them Google stuff, then that's like a pretty good way to find if they're a good fit.
Sorry, go ahead.
Yeah, go ahead.
Sorry, I probably wouldn't figure out if they know by heart how fold looks like, or fold L or R or all the versions in Haskell or whatever. Right? I don't really care about that. I'd probably be acting as their Google as much as I can, or even Googling on my laptop or stuff But do you understand that this requires a fold, or do you understand that and not to think about, hey, this would be a while, or in terms of imperative, but maybe the basics of declarative style programming.
Mm-hmm. One thing I'd be sure to not consider is their knowledge of all the libraries in the language. Concepts are important. So if you want to test that they can use a library, then test them on how they solve a problem that requires that concept. Yeah.
Right. Yeah. So that's what I meant with asking questions about fold. So one of the interesting questions that I usually have is, can you implement fold in terms of map? Just using map without using recursion, and that generally generates some good discussion around it. So things like that, basically. And if you can do it, then how would you do it? That kind of a thing. So.
Yeah, I think there's no science for hiring though.
Yeah, I mean it's hard, but also very important.
I hear that trying to find the hiring process is very much like the dating process. So if you want to be better at hiring, maybe you should try dating a lot of people, and then maybe you'll glean some nice insights from that. It's like, boss, this is for work, please. I'm busy all week. I've got so many dates to go on.
Yeah, my wife would disagree with that, I think.
No, it's for work. She must understand.
And it would be also additionally awkward since a couple of the interviewees are ex-students of hers, so that's probably very inappropriate. That's what she teaches, so yeah. Okay.
But yeah, you can do interviewing over Skype too, technical interviews. I know that I've been interviewed over Skype, and they had me write some code. I think they emailed me a file and had me work with the file, and then I had to screen share. Yeah, so for Anupam, if you need to do remote interviews, it's possible if they have a computer that they can work with.
Oh yeah, sure. I mean, but since we're doing local hires, then it's sometimes I usually get a better gauge of the personality and whether they would fit in.
It's nice that you found several people that you can interview about for functional programming position.
Well, I mean, it's a large city, and we have a few universities here, so there's a lot of not a lot, but there's quite a few people that graduate computer science and mathematics colleges. So we have at least 2 or 3 that are pretty decent. And where my wife is a professor at, they have a Haskell course there, which is not exceptional, but
wow, that's nice.
Yeah, at least I don't think there's any other company other than the company I work at that does a lot of functional, maybe just very little here and there. So there's not a lot of people with experience, but there's new graduates that at least have an idea about declarative programming and get some a bit of Haskell knowledge. So hopefully that will be enough.
Yeah, students have I've met lots of students who have done some Haskell or PureScript or something. So that's always a good source these days.
No, I think the University of Minnesota has Haskell people over there. I know at the local meetup, there's people that come from the university. At least at least a couple years ago. There's some that use it for their high performance computing projects.
Okay, I don't.
I think they have some courses over there for Haskell, don't they? You might know better than me. I think you're looking at courses over there.
Yeah, I've been staying away from computer science, to be honest.
Yeah.
I just don't trust universities too.
Yeah, that's there's truth to that.
When I was looking this semester, I found like a Scala course, I think. But then I saw they didn't have like all the fun type features, and I was like, nope.
Yeah, I want to learn Prolog. That sounds like so much fun. Like stuff that's not Scala, but like even further into like the more academic realm.
There's actually quite a bit of like cute logic in Prolog, like the logic behind it. Like that's literally what my wife is teaching this semester. So
she's
like,
teaching Prolog.
Logic behind Prolog, yeah.
Oh, cool! You should have her come and teach us Prolog.
She'd love to, but I think she loves to do it in a way that's a bit too math even for my taste. So it's a bit rough.
I mean, there are probably Haskellers at the U, but yeah, maybe not a course. Maybe.
Are you a student, Mana, musician?
I'm in high school.
Yeah, you're a student. Okay. Because there's that LambdaConf thing, and they have like student applications. Like you can apply to go and you can like a student, whatever. I had you in mind when you were there when I saw that they're looking for students to apply.
Yeah, I might look into that next year. But.
Yeah. Well, I think we're past our time allotment, so we better shut down here.
Okay.
Yeah, it's been fun chatting with everybody.
Yeah, thanks for hosting it, Alex.
Yeah, and thanks Anupam for showing the Concur thing. That looks more exciting and more exciting than I thought it would be.
Yeah. Thanks for inviting me, and I would really like it if people contribute and just help me build it up more and build more widgets and stuff like that, just to test out the ideas.
Widgets. Well, that's one thing I wanted to ask you about, like the name widget. It's like, it's like the terms that are used for things in computers that are in software that's just not well defined. Like the helpers, like the helper classes in Java land, or
managers.
Yeah, so my background is that it came from Fudgets. I don't know if you've heard of this library in Haskell called Fudgets. It's like really old, probably like 20 years old or something. So they had a nice UI model, and they had like widgets and gadgets and stuff like that. So I really liked it, and so widget is a window gadget, apparently. Yeah. It's a gadget with a window, and a gadget is just like a pure effect. So it's just
yeah, I know Windows, maybe Vista, like they had the sidebar thing, and like the things you put in the sidebar, I think those are called gadgets. And I remember thinking that was so weird. The name they call it gadgets.
Right.
A multi-billion-dollar corporation, and that's the best thing they can come up with to describe those things you put in the sidebar is gadgets.
Well, yeah, you can look at Apple. Everything is like very simplistic, right? Just Word and stuff like that.
Right.
Yeah. So yeah, I just thought that anything with a UI, a widget is like a very generic sounding name. Mm-hmm. It could be anything. It just suggests possibilities.
Mm-hmm.
Yeah.
And did you say that the design of Concur was heavily based on Reflex?
No. So I was using Reflex in a project before, like maybe a year and a half ago. So some of the things that were problematic with Reflex was what motivated me to build Concur. In fact, it started off as I was going to build it as a layer over Reflex. And then I realized that I can just implement it on its own. I didn't need the rest of the machinery that came with it. Yeah. So, but it was mostly inspired from Widgets, as I said, which is
Widgets. Okay. Yeah, I was curious about that.
Yeah. So that was more of a data flow kind of a thing. But the idea was that you have widgets that can just be composed together. Reflex is not very composable. You don't compose widgets together, but you like extract events out of widgets and then you compose those events. But because of the separation between events and widgets, it just becomes a little bit more muddled than it's not very clear when you're reading it later. So I wanted to remove that separation.
Yeah, I'll take a look at that later.
Yep.
Well, I bet it's pretty late over where you are, Anupam.
Yeah. It's like 5 a.m. or something.
Oh, goodness.
Yeah. I usually stay up to like 2 a.m. or something. So, but I really wanted to attend this. I'm getting started with PureScript quite a bit, like getting deep into it now.
You said that you're using it for work?
I am, yeah.
That's exciting. Congrats, man.
Yeah, it's really great. After building a lot of stuff with Haskell, PureScript has also been like really great. It's like a breath of fresh air.
Yeah. What's your favorite part about using PureScript relative to Haskell?
So a lot of things are. I really liked effects like row types, effects, and I understand that that's going away, which kind of made me sad. But I really like that, and also I like the AF library. I think because AF is implemented in JavaScript, it comes with a lot of things that you normally don't find with Haskell. So in Haskell, I use STM, which is really powerful and really nice. And there isn't an analog in PureScript as far as I know. I searched and I couldn't really find anything useful.
Which one? STM?
STM, yeah. So STM is kind of
transactional memory.
Correct. Yeah.
Okay.
So that really helps with all the asynchronous stuff. It just makes everything correct, like provably correct. But with PureScript, I couldn't find anything like that. But the AF library seems really powerful. I was just looking at the documentation, and it seems to have a lot of things. And I think I won't need STM. I can just use AF everywhere, and it'll just work fine. And especially, I like the parallel and I don't know what I forget what the library is called, but there's a monad parallel or something, and AF has an instance of that. One thing I just ran into recently was why don't we have a functor instance for avars? It's just something that I had to implement myself.
How would you? You would have to like map the read, right? You wouldn't be able to set it anywhere, right? The avars? Like
so I'm not sure what the internal implementation of avars looks like, but so in Concur, I just want the avar to hold the next widget that's going to be rendered, right? So I wanted to, and the way the free monad implementation works is that you just fmap over the structure, and when you bind, it just fmaps over the whatever structure you're using, the functor. So I really need a functor instance for avar. And so what I'm doing right now is I'm just using a Koyoneda thing, which is just like so just to simulate functors. But I was wondering if there's a technical reason for not having it.
Well, so how would put var work if you have a put var?
Yeah, if I wanted to implement it myself, I could have done just like get the variable out from an avar and then just put it, and which return like the fmap value, right?
Well, they're represented as actual like things in JavaScript, right? And we're talking about JavaScript part, right? And then you'd have to create a new avar inside of fmap, which would make fmap needing to be inside f, which you can't do, right? Or like have side effects.
Oh, so is it something that can't be done, or is it something that's
I think
inefficient?
it can't be done. It cannot be done because like fmap doesn't run inside f. And then if you need to map an avar A to avar B, they need to create an avar of type B, which is an f thing, right? It's an effect.
Okay.
So if you, I still think you need invariant. So if you want to support put on your data type still, you would need invariant or something. And so here's a profunctor. Here's a unata or co-unata for profunctor, I think.
Okay.
And so if you do, this might get a little crazy, but if you do a join on that, you can get back to an invariant functor. So that basically says your internal variable, it can be of whatever type. And then if you're going to do a put into it, you're going to have one function that you apply to it before that. Then you have your variable, and then you'll have a function you apply it on the way out to get back to your like interface type, whatever type it says it is.
Right.
Whereas internally, it just becomes an existential of whatever type.
Okay, cool. I'll take a look at that. I'm not very familiar with invariant functors, but I'll just read up on that.
Okay.
Cool.
I think the STM thing is like in JavaScript, you have a bit more like guarantees, safe, like threading guarantees. Like you cannot have two threads that run at the same time and like do something something in memory. So you don't really need STM, I think. Or like if you do, then it's because like a function runs until it's end, right? Or until you do something with it.
Right. Yeah, if I drop down to JavaScript, I think it's going to be easy. And I may not need, as I said, I may not need STM anyways because I thought that the AF library looked sufficient just by looking at the interface. So yeah, I'll just try to implement it using that.
But yeah, the AF thing is just like the Haskell's runtime, asynchronous runtime, as I understand it. Yeah.
Right. Yeah.
Oh, yeah. Well, yeah, we got to shut down for real, man. We got to shut down. It's been fun chatting.
Okay. Great talking to everyone.
Yeah. Hope to see you guys all next time.
Okay.
Bye now.
Okay.
Thanks,
Bye.
Alex.